look at graphing trig functions in this video. So when we have our trig functions, we have a general form here, and you may see this slightly differently from textbook to textbook, but the basic features that we're looking for is this number that's in front, that's our amplitude. The number that's with the x, or the theta, is our coefficient that we use to work out the period. So whatever value is there, we're going to do 2 pi divided by that number. If we've got in the brackets a plus c there, that's a horizontal shift, or what we call a phase shift, which means it's moving it horizontally forward or backward. And then we've got our plus d on the end, which is our vertical shift. So just be careful where these brackets are. If this plus c is inside the bracket, it's your horizontal shift. If it's just on the end, it's your vertical shift. Now, when we have a basic sine curve, it has the shape of, and I like to call it like a mountain and a valley. Its standard period is 2 pi, so this is our y equals sine x. And it has that shape. Obviously, the halfway point is at pi, and our amplitude is 1, so it goes up to 1, and it goes down to -1. If we moved the whole thing up vertically, that would affect our maximum and minimum values, but our amplitude will always tell us how far it is from that mean value, which in this case is our x-axis. Our cos curve is very similar and can use the same patterns and features that we've got in our general form up here. Just put in a cos. It just has a different shape. So it starts with half a mountain, valley, half mountain. And so it's like a sine curve that has had a phase shift. So it's been shifted forward or backward pi on 2. So if we imagine that we got our sine curve and we shifted it back, we will get our cos curve. If we've got our cos curve and we shift it forward, we would get our sine curve. Now, I put this to the side here just to understand where these values are coming from. So when we do sine of 0, we would get 0 on our unit circle if we're working that out. If we had our pi on 2, our sine is always the y coordinate of that. So that is 0, -1, the y coordinate, positive 1, sorry. So the y coordinate is 1. That's where we get our 1 here. When we're at pi, we're back at 0, and 3 pi on 2, we're at -1. And then back to the start at 0. So our sine curve and cos curve, they do keep following on, but we tend to look at them for one cycle or from 0 to 2 pi. If we were putting our values in here, we would have our 2 pi there, our pi here, our pi on 2 there, and our 3 pi on 2 there. Another thing that some people like to put on their sine and cos curves are to label those intercepts, the x-intercepts and the y-intercepts on there as well. Having a look at a couple of examples just for each of the features that you might see. So the first one we've got is 3 sine x. So in this case, our amplitude is the one that has changed. So when we draw our picture, our graph, sketching our graph, we need to make sure it goes up to 3 and down to 3, down to -3. So we've got 3, -3, 0. Our increments along the bottom are going to be the same. So we've got our 2 pi, pi, our pi on 2, and our 3 pi on 2. And so we know it's going to have that general shape. So we've got our coming up to 3, down to -3 there, crossing over at pi, and our period goes from 0 to 2 pi. When we look instead at sine of 2x, our amplitude is 1, but it's our period that's changed now. So we've got 2 pi on 2, so our period is now pi. So we're going to still do one cycle, but we're going to do it in 1 pi instead of 2 pi. So our amplitude is just 1, but a -1. We've got no horizontal shift or vertical shift, and so we put our pi there. That means our halfway point is going to be pi on 2. Halfway there is going to be pi on 4, and then this one's going to be 3 pi on 4. So then we will do our shape there, and if we were asked to show it to 2 pi, we would put in another cycle as well. Here we've got sine of a half x, so our period now is going to be 2 pi on a half. When we divide by a half, we get 4 pi. So now we've got our same shape, but it is over 4 pi. So when we do our first little increment there, we've got our 4 pi, halfway is 2 pi, half of that is pi, and the 3/4 is 3 pi on, oh sorry, it'll be just be 3 pi. So going up to 1, down to -1, and we've got our shape in there, and that is our sine of a half x. Then we've got a y equals a negative sine x. So that means that we are going to flip our function. So instead of going a mountain and then a valley, we're going to go valley first. So everything else is going to stay the same. So our period's still 2 pi and our amplitude is still 1. So we'll put our 2 pi in, our pi on 2, 3 pi on 2, and then we're just going to go down first. So we're just flipping a reflection of that sine curve. Then the lucky last one that I'm going to show you is where there's a vertical shift. I'm going to keep the phase shift for another video when we do that. And so we've got everything is the same except it has been shifted up 3. So I'm just going to make my line a bit straighter there. I'm going to make this my 3, and then I'm going to put in some little lines to help guide me. So I've got my 3. I've got to go up 1 and down 1. We should make that a little bit different there. So I'll be going up to 4 and down to 2. And then I'm going to put my curve in there. So need my increments, 2 pi, pi, pi on 2, and 3 pi on 2. And then I'm just going between those dotted lines there. So I'm going up to 4, down to 2, rather than between -1 and 1. So I've still got that amplitude of 1 from 3 to 2, and 3 to 4 from my maximum and minimum values there. Same period, same increments along the x-axis, and same shape. So we will go into the phase shift ones in another video because that adds another layer of complexity there.